Today we're going to look at Lesson 1-6 on relations. We're going to look at how to represent relations and interpret graphs of relations. There's a few different ways of representing relations. Basically, a relation is a set of ordered pairs. So you can write the relation as a set of ordered pairs, which is what we have here. You can see that we have three ordered pairs here. 1, 2, -2, 4, and 0, -3. After already writing down your definitions, you should know that an ordered pair is set up x, y, which means the x-coordinate comes first, followed by the y-coordinate. This will tell you how to graph the ordered pair. So the x-coordinate should go at whatever x. Okay, let me back up and say this again. So the x-coordinate will go on the number on the x-axis, and the y-coordinate will tell you where to go on the y-axis. Then we have a table. A table is another way of writing a relation. So if we're taking the same ordered pairs as we used previously, we have the 1 as the x-coordinate and 2 as the y-coordinate. So we've set up a table where the x-coordinates are all listed on the left side, right here, and the y-coordinates are all listed on the right side, here. We can also represent the relations as graphs and as mapping. I like to say these are called mapping diagrams, but they're also technically just called mapping. So if you were to graph the ordered pairs, like I was explaining before, you would go to where the x-coordinate is, and this ordered pair is actually a little bit off. It should be here, okay? But you would go towards the x-coordinate. So if we were looking at this ordered pair here, the 1, 2, that tells me on the x-axis, which is the horizontal line, it would be at the 1. And then if you have 2 as the y-coordinate, that means you would go up to the 2 on the y-axis and have your point. Next, we have another ordered pair, -2, 4. Again, notice you have on the x-coordinate, the x-coordinate is on the x-axis at -2, and the y-coordinate 4 is going to be up at the y-axis at 4. Okay? And the last one, 0, -3. You would need to go nowhere on the x-axis, so that's why it's directly right on the line for the y-axis at -3, because the y-coordinate is -3. And then lastly, representing a relation, you could use a mapping diagram. This is similar to a table where you have the x-coordinates listed in one circle here in the oval, and the y-coordinates listed in the other. Okay, usually you would put an x at the top and then a y at the top of the other mapping diagram. And then the only difference really between this and the table is that you are connecting the two ordered pairs with an arrow. So the two coordinates with an arrow to make an ordered pair. So if we have 1 as the x-coordinate right here, you would connect that to the 2 with an arrow because it is the y-coordinate of the same ordered pair. So now we're going to try and represent the relation listed here as a table, a graph, and a mapping diagram. It's already listed as ordered pairs. So we have 4 ordered pairs, 4, -3, 3, 2, -4, 1, and 0, -3. To represent that as a table, I'm going to set up, that's the highlighter. I'm going to set up my table with the x-coordinates on the left, the y-coordinates on the right, and I'm going to list them. So I'm listing all the x coordinates, and then I'm going to list all the y coordinates. Oops, -3. And make sure you match them with what the x coordinate is. So these all came from the ordered pairs above, and now we have our table. Our mapping diagram, like I said, is very similar, so let's just do that next. We set up with an x oval and a y oval. We're going to list the x coordinates and the y coordinates, and we're going to connect the coordinates that make up the ordered pair with an arrow. The thing to note about a mapping diagram is you're usually not supposed to repeat any numbers, so if you ever have any x coordinates that are the same in two different ordered pairs, or same thing with the y coordinates, you would only write them once, and then you draw the arrow from that coordinate. You'd have to use that coordinate twice and draw two arrows from that same coordinate if you have any repeats. But in this case, we don't have any repeats. And then the last representation is going to be the graph. I'm going to erase this here. We're going to draw the y-coordinate. The y-axis. I keep switching the axis and the coordinate. And the x-axis. And then we look at our ordered pairs. If we're going to go from to 4, -3, that means we're going to go 4 to the right. Okay, we always start at the origin, which is in the center here at 0, 0, right there. Right there. And you're going to go over to the right 4, because it's +4, and down 3, because it's -3. Okay, kind of hard to do a dot here. All right, so that is our first ordered pair, 4, -3. Our second is 3, 2, so again we're going to go to the right 3 because it's a +3 for x, and up 2. So that's going to be 3, 2. And then we'll have -4, 1, which this is a negative x coordinate, so it goes to the left from the origin, 1, 2, 3, 4. And we're going to go up to 1 on the y-axis, so that would be our ordered pair. And then our last ordered pair, 0, -3. 0 means we're going to go nowhere on the x-axis, we're going to stay at the origin, so we're going to just go down the y-axis 3 spots because it's a -3. So we have 0, -3. And then part of the same problem is it's asking us to determine the domain and range. You need to just know that the domain is the list of all x coordinates. You don't usually need to list any x coordinates twice. You just list them once if there's any repeats. But the domain is x coordinates, okay? So we say a set of x values, and the range is the set of y values. So when you have them listed in a table or a mapping diagram, it makes it a little easier to see the set. But if we're going to look at the order pairs, we can just look at the x coordinates and list those as my domain. So we have 4, 3, -4, and 0. So that would be my domain. And then we look at the y coordinates, which is the range, and we list those. So we have -3, 2, 1, and another -3. So in this case, we actually don't have to list the -3 twice. Okay. And going back to that same idea where we do have a -3 that repeats, I don't think I caught that before I did the mapping diagram, but for the mapping diagram I would have only written -3 once, and then I would draw 2 arrows towards it. So let me actually show you what I mean by that. So you can see here I redid my mapping diagram to only put -3 once. And since I have the -3 as my y coordinate and it's repeated, I'm going to have 2 arrows going towards the -3. The one arrow is going to come from the 4 because it's an ordered pair with the -3. So we have 4, -3 as one of our ordered pairs. Then the other one that has the -3 as the y-axis is 0. So 0, -3. Then the other 2 would just go to their respective y-coordinates also. Okay, so it looks something like that. Next we're going to look at this scenario where we're talking about an air pressure of a tire and how it's increasing with the temperature. So the higher the temperature, the more air pressure you're going to have inside a tire, and then vice versa, the lower the temperature, the lower the pressure inside the tire. So we are trying to identify the independent and dependent variables. So if you think of the words independent and dependent, dependent is going to depend on something else. Independent is going to remain the same usually and is not going to be able to be changed by anything else. So if you see the scenario here, we have 2 different variables. We have the air pressure, and then we also have the temperature. So the air pressure is increasing with the temperature. That means the air pressure changes based on the temperature. So since it changes based on something else, that means the air pressure has to be dependent. It's called the dependent variable. The temperature is not going to be affected by anything. It's affecting the air pressure, so it remains the same. It's independent. Okay, so it would be independent. Same idea with the next example here. We're looking for the independent and dependent variables. So we first need to identify the variables themselves. So we have the amount of rain decreasing, and the water level of the river is also going to depend on the rain, because it says as the amount of rain decreases, so does the water level of the river. So if it's dependent on the rain, okay, the water level is going to be the dependent variable. So whatever is the dependent part of the sentence or scenario, that's going to be your dependent variable. So if that's the dependent variable, the rain is not going to be affected by anything here. It's going to come no matter what. So that is going to be the independent variable. So that's the type of thinking that you want to use with these types of problems. Finally, we're going to describe what's happening in each graph. So, without having any numbers attached to it, we're thinking about the scenario of driving to school and what it looks like on a graph. So you can see the x-axis represents the time, and the y-axis represents the distance left going to school. So we're going to start at a standstill, it looks like, and then we are going pretty fast up. So that means it looks like we're going at a steady pace driving to school. Then there's a break where there's no driving going on, but time is still passing. You can see that with the flat part there. Same thing with the next flat part. So you're supposed to think about what might happen that would cause time to go by but you to stop driving. Could be that there's a light, could be that we're stuck behind a school bus, but it's up to you what you would want to describe. There is one section where it's a little slower. That could be right here. That would be maybe traffic, something like that, but you're supposed to describe the line. So you're going at a steady pace. You stop at a stoplight, then you get behind a bus, so you're going a little slower. Then you stop for the bus stop. Then you're going back to your steady pace. So that would be something that you could say when you're describing this particular graph. The other graph, the change in income is what you make at a job when you work. So as the time goes by, it looks like the change in income is always increasing. That's a good thing. That means that you must be working hard. And that's what I would say about that graph is as time goes on, your income is increasing and you should be working hard at your job to be making the increased income. Also, the more time you work, the more money that you usually make because you're working more hours. And that is the end of Lesson 1-6.